Hello everyone, welcome to my YouTube channel AV Classes. Our last topic in ray optics is the simple and compound microscope. Subscribe and share my YouTube channel. So let's start. See, simple microscope is an optical device which consists of a convex lens of short focal length and which is used to see a tiny object clearly. See, this is the diagram of simple microscope, which is consists of a single lens. Now here we will study about two cases. One is when the image form at finite distance, and other case when the image form at infinity. Now here a term arrive which is called D. This D is called least distance of distinct vision, which is defined as the minimum distance at which a normal human eye can see an object clearly. It is about 25 centimeter. Now let's suppose this is the AB is object, A dash B dash is the image formation, okay, and this is the human eye. Now, this lens is adjusted in such a way that image form at D. Okay. Now, here we will define a term called magnifying power. Magnifying power is defined as the angle subtended by this image at this D, means at least distance of distinct vision to the angle subtended by this object at least distance of distinct vision, that is beta upon alpha. So, magnifying power is defined denoted by m, which is equal to beta upon alpha. Now beta and alpha are so small, very small, so that we can take it as tan beta upon tan alpha. Tan beta upon tan alpha. Now what is tan beta? Tan beta is AB upon this x. AB upon what? Let's say this is O. AB upon OB upon tan alpha is what? When same object placed at distance D, then we can say A double dash B dash upon what? This OB dash. Now see, this A dash, A double dash, B dash and this AB are equal, so it is cancelled out and it become equal to OB dash upon OB. Now OB dash is what? OB dash is what? D, but it is left side of this lens, so we take negative sign, that is equal to minus D upon minus X. X is this OB. So this magnifying power is what? Equal to D by X. This is the expression for magnifying power. Now we can also denote it in term of focal length. See how? Use lens formula here. So using lens formula, what is lens formula? 1 by f is equal to 1 by v minus 1 by u. Now this 1 by f is, v is what? V is the image distance, and image distance is at d minus d. So minus 1 by d minus u is what? U is what? This x, which is equal to minus x, which is equal to minus 1 upon d plus 1 by x. Okay. Now multiply by d both sides, then d by f is equal to minus 1 plus d by x. This implies d by x is equal to 1 plus d by f. Now this d by x is what? This d by x is what? Magnifying power. So m is equal to 1 plus d by f. So this is the expression for magnifying power of a simple microscope when object form at a finite distance. And for object form at infinity, very simple case, because when object form at infinity, this is not here, this is like this, and in that case the object must be placed at focus. In that case the image form at infinity, and when the image form at infinity, then this magnification, I can erase it. Then the magnification is what? Beta upon alpha. But in that case beta is what? Object is here, then beta is what? This h upon focal length upon tan alpha is what? Alpha is also at infinity. In that case we can say h upon t, not at infinity. In that case, for case of alpha, the object placed at distance d, h, then h by d. Now h is cancelled out, so we left with d by f. So when object form at infinity, the magnifying power is equal to d by f, and when object form at finite distance, then magnifying power is what? 1 plus d by f. This is for what? Finite distance. This is for finite, and this is for what? Infinite. Okay, now let's start compound microscope. See, compound microscope consists of two lenses. One is called objective, another is called eyepiece. Objective has shorter focal length, eyepiece has larger focal length. Okay, here this, let's suppose this is object AB. Now one image formed at here A dash B dash, and this A dash B dash act as a virtual image for this eyepiece, and another image formed at A double dash and B double dash. Okay, so here magnifying power is what? M. Magnifying power is what? Tan beta upon tan alpha. Same concept here. Tan beta upon tan alpha. Okay, what is tan beta? H dash upon UE. And what is tan alpha? Tan alpha is this same thing, h upon d. H upon d. So which is equal to h dash upon h into d upon UE. Now we in lenses we define a term called magnification. So m is equal to what? This h dash upon h is what? H dash upon h is what? Magnification of this objective lens. So let's denote it by m naught into d upon UE. D upon UE is what? D upon UE is magnification of this eyepiece. Let's suppose this is ME, where M naught is what? H dash upon H, and ME is what? D upon UE. Now, for M naught, we can also write H dash upon H is equal to V by U. V by U, V naught upon U naught. Okay, and this eyepiece now act as a simple microscope, and magnification for a simple microscope is what? 1 plus d by f for finite image. So it is equal to 1 plus d by fe. Now put here m is equal to, see, this object is very close to focus. So our object distance is what? Minus f, v naught upon minus fo. So this become equal to minus v naught upon f naught into what? 1 plus d upon fe. So that's all about the magnification or magnifying power of a compound microscope when object form at finite distance. But when object form at infinity, then we use this formula in place of here. This is for finite distance, but at infinite distance the magnification is what? Minus v naught upon f naught into d upon fe. This is for infinite distance. See, डायग्राम थोड़ा लेंदी है बट कैलकुलेशन बहुत सिंपल है, इसका यूज करना है. ये चीज आपने आसानी से समझ लिया कि मैग्निफिकेशन जब फाइनाइट डिस्टेंस पे हो तो 1 प्लस डी बाई एफ होता है, इनफाइनाइट पे हो तो डी बाई एफ होता है. वो चीज हमने यहाँ यूज कर दी क्योंकि आईपीस जो है एक सिंपल माइक्रोस्कोप की तरह ही काम करेगा, एक सिंगल लेंस है तो, है ना. तो उसके लिए हमने फार्मूला यूज कर दिया, फाइनाइट के लिए ये होगा, इनफाइनाइट के लिए ये होगा. वी नॉट ये डिस्टेंस आपको पता होगा, एल मान सकते हो इसको, तो एक्सप्रेशन वी नॉट से एल में चेंज हो जाएगा. ठीक है, so that's about all about it. Thank you.